Good day mga netizens, it's your boy here. Why did I just say my name? My boy. Anyways, so let's try example 3 from your fourth module about entropy. Let's read the problem. Zinc melts at 420 degrees Celsius or 693 Kelvin, and its standard entropy at 25 degrees Celsius or 298 Kelvin is 9.95 calories per mole Kelvin. Calculate the standard entropy of zinc at 750 degrees Celsius or 1023 Kelvin. We are given the following data. The latent heat of fusion is 1.74 kilocalories per mole or 1740 calories per mole. And the CP for zinc solid, or the heat capacity for solid zinc and liquid zinc, are listed as follows. So for zinc, we are raising the temperature from 298 Kelvin to 1023 Kelvin. So along the way, so let's put this as ito, 298 and 1023 Kelvin. And let's zoom in. Along the way, there will be a phase change converting your zinc from solid to liquid. And from the given, we know that that will occur at 693 Kelvin. 693 Kelvin. Graphically, we can express yung 298 Kelvin to 1023 Kelvin ni zinc as follows. So at 298 Kelvin, your zinc exists as a solid. Then it will increase in temperature until it reaches 693 Kelvin. Then, since 693 Kelvin, meron kang phase change dyan, magiging liquid siya, zinc liquid. Then it will increase again in temperature until it reaches yung target temperature natin na 1023 Kelvin. So each of these arrows or each of these processes have a corresponding entropy change. So we can name this as delta S1, delta S2, and delta S3. So si zinc natin, solid, at standard state, S1, sorry. So at its standard state, yung S nito or entropy formation at 298 Kelvin, this is equal to, from our example kanina, is 9.95 calories per mole Kelvin. So, ang hinahanap natin sa problem is what is yung entropy of formation or yung entropy, standard entropy ni zinc at 1023 Kelvin. So, using yung ating properties for our state functions, that doesn't matter kung ano yung process natin, basta initial and final lang yung makakuha natin, we can exploit that by combining S1, S2, and S3 natin para makuha yung value ni S1023. Or mathematically, it would look something like this. So, final S1023 Kelvin minus initial S298 Kelvin would be equal to the sum of all of these processes kasi ito lang yung delta S natin. So, equal lang yan sa delta S1 plus delta S2 plus delta S3. We're looking for S at 1023 Kelvin. So, we can isolate this one. We have S at 1023 Kelvin is equal to S at 298 Kelvin plus delta S1 plus delta S2 plus delta S3. So now let's just look for expressions for delta S1, delta S2, and delta S3. So going from one temperature to a higher temperature, yung delta S natin is just equal to the integral from the initial temperature, so in this case 200, so delta S1 298 Kelvin to 693 Kelvin. And in-integrate natin dito is Cp, or in this case Cp of the solid, over T dt. Substituting our values, this will be 298, 693. And yung CP natin dito, which is 5.35 plus 2.4 times 10 to the negative 3t. So it will be 5.35 plus 2.4 times 10 to the negative 3t. And all over t, dt. For delta S2, this is an isothermal change. So yung ating, this is an isothermal na phase change. And yung ating equation lang dito will be yung latent heat of fusion over the temperature is equal to 1,740 calories over yung temperature of transformation niya, which is 693 Kelvin. And for delta S3 is just yung from 693 Kelvin to 1,023 Kelvin. And we now have yung CP ng liquid over T dt, or this is equal to 693 to 1,023, 7.5 over T dt. So incorporating, putting all of these into our equation, we'll have S 1,023 is equal to S of 298. At 298, again, this is 9.95. 9.95 plus delta S1, which is 298, 693, 5.35 over T plus 2.40 times 10 to the negative 3 dt plus 1,740 over 693 plus 693 to 1,023 of 7.5 over T dt. Evaluating this one, we'll get S of 1,023 Kelvin is equal to 9.95 plus 10.8495, or this will be equal to 9.8495 plus 9.95. This is equal to 20.7795 calories per Kelvin. So that's how you solve that kind of problem. Thank you, and I'll see you on the next recording.